Space is not silent. Across the universe, enormous explosions release more energy in seconds than our sun will emit in its entire lifetime. These events are so bright they can outshine entire galaxies. Astronomers detect them from billions of light years away, acting like cosmic beacons across time. By studying them, scientists can see the early universe, measure expansion, and understand how matter itself formed after the first generations of stars ended violently. The most famous cosmic blast is the supernova. When a massive star exhausts its fuel, gravity crushes its core instantly. The outer layers rebound outward at incredible speed, forming a shockwave expanding through space. For a short time, a single dying star can shine brighter than hundreds of billions of stars combined. The heavy elements inside your body, iron in blood and calcium in bones, were created in explosions like these. Some supernovae are even more extreme. Called hypernova, they occur when stars dozens of times heavier than the sun collapse into black holes. Their cores spin rapidly and fire enormous jets through the star's poles. These jets punch through space and produce gamma ray bursts. For a few seconds, they release more energy than the sun will produce in 10 billion years, making them the most luminous flashes ever observed. Gamma ray bursts were first detected accidentally by Cold War satellites monitoring nuclear tests. Instead of human weapons, instruments recorded flashes from deep space. Scientists soon realized they were witnessing distant stellar deaths billions of light years away. Because light takes time to travel, every burst acts like a time machine, showing what the universe looked like when galaxies were still young. Another colossal explosion occurs when two neutron stars collide. These city-sized objects contain more mass than the sun compressed into a sphere only kilometers wide. When they spiral together, gravitational waves ripple across space-time itself. The collision produces a kilonova, a blast forging gold, platinum, and rare elements. Much of the jewelry on Earth was created in such violent cosmic mergers long before our planet formed. Magnetars also unleash terrifying outbursts. These neutron stars possess magnetic fields trillions of times stronger than Earth's. Occasionally, their crust cracks, releasing a starquake. The resulting flare can affect space across the galaxy. One detected flare briefly altered Earth's upper atmosphere from across the Milky Way, demonstrating how powerful even a distant event can be. Black holes can trigger explosions without exploding themselves. When matter spirals into them, it forms an accretion disk heated to extreme temperatures. Magnetic fields channel energy into massive jets moving near light speed. These jets stretch across galaxies and blast surrounding gas for millions of years. Entire star systems can be disrupted by activity around a single supermassive black hole. Quasars represent the brightest sustained explosions in existence. Powered by feeding black holes at galactic centers, they release continuous radiation visible across the observable universe. Some quasars formed when the universe was less than a billion years old, helping astronomers study early cosmic history. Their light travels so far that observing them means looking almost to the beginning of time. Occasionally, stars are torn apart entirely. When a star passes too close to a black hole, tidal forces stretch it into a long stream of gas. This tidal disruption event produces a flare brighter than the galaxy itself for months. The event marks the complete destruction of the star, providing direct evidence of hidden black holes in distant systems. Fast radio bursts are brief but powerful signals lasting milliseconds. Their origin remained mysterious for years. Now scientists know some come from magnetars releasing sudden energy pulses. Though short, each burst carries enormous energy. If one occurred nearby, it could disrupt satellites and communications, reminding us cosmic explosions still influence modern technology. The early universe hosted explosions far greater than those today. The first stars were enormous, hundreds of times the sun's mass. When they died, pair instability supernova completely destroyed them, leaving nothing behind. These events seeded galaxies with the first heavy elements, enabling planets and eventually life to form billions of years later. Galactic collisions also produce energetic outbursts. When galaxies merge, gas clouds compress and trigger massive star formation. The newborn stars quickly die in chains of supernova, creating starburst regions glowing intensely. These regions can reshape galaxies entirely, changing their structure over cosmic time. Cosmic explosions help scientists measure distance. Certain supernovae have predictable brightness, acting as standard candles. By comparing observed brightness with expected values, astronomers calculate how far galaxies are. This method revealed the accelerating expansion of the universe, leading to the discovery of dark energy. Not all explosions destroy, some create. Shockwaves from supernova compress nearby gas clouds, triggering new star formation. Entire stellar nurseries may begin because of a single ancient blast. In this way, destruction, and creation are connected processes shaping cosmic evolution continuously. Earth itself carries evidence of past explosions. Radioactive isotopes in ocean sediments indicate nearby supernova occurred millions of years ago. Though distant enough to avoid extinction, they likely affected climate and radiation levels. The universe is dynamic, and our planet has always been part of its changing environment. From brief flashes lasting milliseconds to eruptions spanning millions of years, cosmic explosions are among the most powerful forces in existence. They forge elements, shape galaxies, and reveal the history of space itself. Every atom around us traces back to ancient blasts. The universe is built not in silence, but in fire.